Hi guys, welcome back to ESC Crazy. Today I am going to be making my own chip with certain components that can be found very easily by us. And this is the third version. But before which I'll pause you for 1 second and talk to you about today's YouTube shout out. So today's shout out is to the YouTube channel Devata Kirtana. So actually I am a huge fan of people who have a good voice and make podcasts, and this channel uh, tends to speak about Indian culture and spiritual side of that, but I am more interested in just learning some interesting stuff, and this channel has done a very good job with that. It's a new channel, but I have gotten to see some more interesting stuff. So the channel's name is Devta Kirtana. I have been following it ever since its start, within I think 1 week or so. Good content, done very well, and it's done by a child, so it's awesome content, and his channel is becoming famous an inch by an inch. So yeah, check out the channel Devta Kirtana. Let's get back to the video. So yeah, I'm going to be using a proto board with holes. Very easy thing, it's a copper plated thing, yeah, and it's 5 by 4 dots, and I'm using a basic NPN transistor that will be the BC547 NPN. You can use even like other series like 2N2222 or the 2N series. I'm using an 470 microfarad capacitor here, but I suggest you use 100 or 1000 or something like that, something below 500. I am going to be using two resistors. They need not be identical, and helping hands and certain equipment, for which you can find links in my website, but mainly what I'm using is a soldering iron, lead and all of those. Purchase links can be found in my website esccrazy.weebly.com, and this is the magnifying glass which I'm using so that I can record comfortably for you guys, and helping hands of course. So I'm going to be starting off with the first step, which is to take all the components and assort it properly, and then I am going to be adjusting my camera a little because I hope that you see the thing clearly, and lighting is perfect, so I think we can begin. So yeah, components roll here and there, be careful with that. So this is actually me documenting my third attempt at making my own chip. I actually had 2 attempts with, and I had also put a blog post in my blogger page telling the thing, and I told that I wanted to make my own chip called the LB101 series, and this is the LB103. So yes, I have inserted my BC547 transistor inside onto the proto board. I am folding its legs down so that it doesn't wobble and fall off the PCB when I solder, and you can do that with tweezers if they are strong, but I do not suggest. So if I'm using a proto board that is 5 dots by 4 dots, and that's a problem, and you will see that very shortly. So it's time to solder. I am using solder that has flux in it, lead rather, and there is a link in my website wherein you will get the best quality one at a very low price at wholesale rates. So it's quite a good deal, and yeah, I have started the soldering process. Just some helping hand issues, but that's all. Actually, soldering while looking at the camera is quite difficult. That's why my movements are slightly different. But if you do this when you're not in front of a camera, it's quite easy actually. And yes, doing soldering like this for some of you might be difficult. So what I have come up with is a PCB along with the BOM file, everything, so that you can purchase the components and the PCB directly from either JLC PCB or lcsc.com. So now I am going to be soldering my capacitor on, and I have a schematic which can also be downloaded for your own reference. So what I'm going to be doing is that I'm going to be connecting the positive and the negative according to my scheme. So the BC547 transistor's pinout goes like CBE, that is the collector, base and emitter, and the base is not connected to anything in this circuit, but later I will also be making an version with that and SMD components and everything. So now you are just going to be seeing a fast-paced video of me soldering on the capacitor currently. So I have finished soldering the capacitor. Now I'm going to be taking two resistors of different values, and this is a simple trick I learned from the YouTube channel Great Scott, but you can use a needle nose plier and bend the resistor so that you exactly get it to cross two pads on the PCB. I didn't do it properly, but you can do that properly and it will work out well. So I'm going to like replicate it and it's done. So the thing is that now I have to like solder it onto my proto board, and the plan was that it will go across the 4 on the other side, but now I think you'll see the problem shortly, wherein I'll be highlighting it for you guys. So now as you can see, I figured the problem out and testing if it's gonna work, but no, of course. So if you see, this is where the mistake occurred. So you are going to see what kind of a problem that's going to cause in the future. But yes, in the same way, I'm also going to be putting the resistor on the other side of the PCB, and you will see as to what these resistors are actually going to make up of this like IC when it's finally prepared. Soldering time, soldering on the resistor legs. So as you can see, they are not very even right now. Plus I haven't connected the capacitor's leg yet, which I will be doing. And I accidentally was about to cut the pin, but I finally remembered and I just acted as if I adjusted it. Just a funny element of this video, of course. I'm sure it's not funny for many of you people. Anyways. So now as you can see, that is where the problem is actually occurring with the distance between the legs, because finally when I'm going to insert it in the breadboard, you can see what's going to happen in the end of the video. Actually, it's a spoiler, but no alerts given. Sorry, but fine. So it's time to solder the other part of the board, and don't forget to subscribe to this channel by the time I finish that, and ring the bell icon, of course. So I'm back, going to finish the soldering part of this IC. Let me tell you guys one thing, that in the final output, one leg of the chip will remain unconnected because the circuit only needs 3. So now I have cut the resistors off and the legs only remain, and I'm going to be cutting them to size so that it doesn't look like Eiffel Tower on top of my breadboard. And yes, the circuit is complete right now. So let's test it on the breadboard. And yes, here is the problem. As you can see, because of my stupid mistake that I made, it doesn't want to fit anymore, and I tried one useless method which was going to work horribly. But finally what I ended up doing was that I just moved 2 of the legs to the side so that they would align with the nearest breadboard hole, and it ended up fitting perfectly, but in the PCB design that I'm going to be providing, that mistake is not there, hopefully, so it is going to be perfect. As you can see, it has been inserted, all pins are in, so the guys don't tell me that this video is fake. Anyways, back to the point. So yes, this is my SMD LED board that I made while testing some SMD electronics out. It worked well and it's still working. So I'm using a multimeter to find the polarity of my SMD LED because I don't know it exactly. And as you can see, my first test worked. So the right side is positive and the left is negative. So I'm going to be quickly connecting it to my breadboard and everything along with the connections. So yes, the schematic has the connections for the LED and everything, but in case you have any doubts, you can always contact me through the description or the email that you can find in the about page of my YouTube homepage, or you can contact me through my blog in the comment section there as well. So I'm going to start by making the connections real quick. The recording of this video is totally unscripted, so as you can see, I'll keep telling many so's and ifs and buts, don't mind it. Pretty much from here I won't be talking because it's all connections, and this is where I got confused thinking I made a mistake with the chip. By the way guys, there will be a part 2 of this chip wherein you can actually see it transform and become like a real chip, because currently it has big stubby capacitors that are poking out, but that will change because I'll be using SMD and everything. So keep on the lookout for part 2, which might come in within the next 2 months. But I won't give you any guarantees, even though I have a 2-month uploading policy from this year. But yeah, and next year my channel is going to be hitting 5 years, I think, and the chip is working. But there is a small thing that I have mentioned in my blog as well, and it is that the chip is extremely voltage sensitive, wherein if the voltage is slightly less or slightly more, it stops working. If it is slightly more, it keeps going like this, and if it is slightly less, it stops working totally. Its sweet spot is somewhere in between 11 and 12.5 volts, and since my analog power supplies are extremely accurate, sarcasm of course, I finally got it to work with great difficulty, but you can see it work in this video, and the chip is then ready. So as you can see, the chip is working, but the timing fully is based on the voltage that you give and the capacitance and the resistance of the soldering job, of course. So yes, hope you enjoyed this video. Don't forget to check out the Takitna. So see you next time. Thank you guys.